Hello, everyone. I want to show you a feature I've been working on. I'm pretty excited about it. It's a replay system. So the idea is in your game, you can start a recording on your world that's simulating your Box2D world. And then sometime later, you would stop the recording. Then you can save that recording to disk. And so right now I'm in uh, the Box2D sample app, and here I've made a replay viewer. So suppose you've sent me a recording of your game. Maybe you have a driving game and you load it in here. So I have driving.b2rec, and I'm going to load it in here. I'm going to give it some memory for viewing. And so it's loaded in here. I'm going to turn off joints. And here's your driving game. And so you had a bug, and now I can go in and see how your game is operating, what's going on in it. I can pause. I can rewind time. I can look at the contact points, the contact forces. I can click on a shape and then get information about that shape and the body that owns it. I can see all the details about what's going on with this simulation. And I can even see the contact data. Let this guy run. You can continue viewing all this. And what's neat about this is not just recording all of that data. This is actually a live simulation. And it makes use of the fact that Box2D has determinism. Determinism is a kind of a first-class feature in Box2D. So that means if you run a simulation in Box2D with the same inputs, you always get the same output. And not only on the same computer, but actually across all computers, including Windows, Mac, and Linux. And with this system, additionally, you will get the capability of rollback determinism. So this system, the way it's built, it requires rollback. So you can actually save a snapshot of the world, run your simulation forward as long as you want, and then reset the world to that snapshot. And if you do all the same inputs that you did before, you can kind of go back to the future and be in the same place. So let me open another sample. This sample, so I'm running on Windows for this video, but this sample was actually recorded on a Mac. And when I play the simulation back, it will generate oh my gosh. Let's turn off those contact points, and I'll do this again. Okay, so the spinner, this was recorded on a Mac, and part of the recording, it's each world step, it's going to record that world step as an event. It's basically just, the event is just, oh, I called world step, here's the time step, here's the number of sub steps. But it will also record a hash of all the transforms and velocities of all the bodies. And so as it plays back in here, it's confirming that those hashes agree 100%, like bitwise identical. So that's the cross-platform determinism. So the way this system works is when you start a recording, it will take an initial snapshot of the world. And so just the very beginning of this recording, this is the initial snapshot. every frame after this, as I go through here, this is no more taking snapshots. Instead, this is just recording all the API interactions. So for this simulation, it's basically just, taking a time step. So it's going to record that time step. And then it's able to deterministically regenerate the entire simulation. Let's look at another one. This one is the washer, and it's pretty heavy. There's a lot of bodies. And what's going on here, this washer recording, it does just have that initial snapshot. But I need memory to kind of build out this replay, and I'll describe what's going on here. So right now it's like getting almost 4 gigabytes, but let's see how much it actually uses. So it's generating keyframes here, and then actually consumed 1,279 megabytes. So what it's doing is every 16 frames, when you view it in this environment, it's going to generate another snapshot every 16 frames. The reason for that is so that when I'm scrubbing here, it's smooth and responsive. So when I go back in time, it's going to find the closest keyframe, then simulate forward from there. But having a keyframe every 16 frames means it only needs to take, up to 15 time steps. So that makes it very smooth. So there's a trade-off there, how much memory you're going to give to the replay viewer. But because this is a debug tool, you're probably on some decent hardware that has a little bit of storage. So you might wonder, okay, well, how big is this recording file? Well, really, like if you look at what happens, the main data in that file is that initial snapshot. So you can let this simulation go for quite a long time and not get a very big recording file. However, generating these keyframes is going to take space. So what happens here is you give a budget of how much space you'll give to those keyframes. And if it starts running out of memory, it's going to start spacing out those keyframes. And then the scrubbing is going to become a little bit less responsive. So that's the trade-off there. And you always want this environment to be using, multi-threading. So this is running on 8 cores. So let's look at something fun. This is the funnel. This shows you that it's capturing body creation and body destruction. So it's creating these ragdolls. They're going into this sensor at the bottom and they're getting destroyed. And all of that is being reproduced. All that logic is being reproduced because it's capturing all the API calls. So you might even see there's bodies being destroyed out of this outliner view and then more bodies being created. But this simulation actually is fairly lightweight. So there's a lot of frames here. There's over 2,000 frames, but the keyframes are only taking 43 megabytes. So this thing scrubs very quickly. YouTube is probably going to compress this pretty poorly. But it does give you a sense of how responsive this is. Another thing that's very useful about this tool, let me open another simulation here, is that it actually can record queries. Now, I think there's a glitch where the first frame is weird, but let's go to the second frame. Yeah, so queries are a little bit weird because they're in between frames, but it is recording those queries. So this raycast here, you can see the hit point and the normal. And this particular raycast is just collecting all hits. And you can actually see all the hits. These shapes are what's hit. You can see the filter properties on this raycast. And then you can see how the raycast, this raycast is happening every frame for the simulation. So you can see how that's proceeding over time. Now you may have some raycasts that are, just happening one frame. I may want to add some feature in the future that helps you search for certain raycasts, or this also does any kind of query. So this is a box overlap, and you can see here this green box is the query, and then this viewer is just kind of drawing the pink boxes for the things that actually overlap. I think there must be a little bit of a buffer here that's giving a little bit extra results here. We can see that kind of evolve as we rewind time. All right, so I think that's it. This feature is out right now, so you can try it out. I tried to improve some of the build instructions to help you get started if you want to use this tool. So hopefully, this, if you never used this samples app before, this has a whole bunch of different samples, and the replay is just one of these samples, but there's instructions where you can run this app and it will take you directly to the replay view. All right, that's all. See you.